So I'm Harry Keane, I'm CEO of Anon AI, and we're automating data anonymization using some AI tools. So the reason we're doing this, and sorry to lower the tone, there's been very academic talk so far, but we think it's the wild west of data sharing in the past. So companies have been collecting data, storing data, using data quite recklessly. And that's been the case in the news recently with Facebook, MyFitnessPal. These sort of stories are just coming more and more pertinent. So what does the future look like? Well, we think it looks a little bit more like this. So highly regulated, businesses have to take much more control over their data and have a better understanding of how it's being used. But fundamentally, we know businesses are going to want to keep on analyzing data and extracting its value. So how are they going to keep on doing that? Well, we think one of the answers is anonymization. So just to take a little example, if you're working with geospatial data, you could start with a very fine-grained view of the world. So you sort of have buckets of individuals that are spread across London, for example, and you could slowly start to tune down the resolution of those buckets so you include more and more people that are sort of indistinguishable from one another. And so this will allow you to do your segmentation analysis, whatever sort of market insight you're trying to do. And you can keep on tuning further and further down until you have effectively a bucket size of people that still allows you to do your job and to do your analysis, but maintains the individual's privacy. So actually on a record-by-record level, that could look something like starting off with a very fine-grained view of an individual. You can start to strip out the exact personal identifiers like names. You could put ages into age brackets and start to remove some of the information from the address. And so you can keep on going further and further down the tree, increasing the bucket sizes of ages, for example, just leaving in information about the city, then the country, and then finally you can end up with a very low resolution record. And really, all this does is effectively make those individual records less distinguishable from the other records in the data sets. And what that really means is that we're helping companies trade off between privacy on the one hand and utility on the other. Because ultimately, if you do start to decrease the resolution of your data sets, that's when you effectively start to lose some of its utility and some of its accuracy. So we have to be very careful about that. And so anonymization allows you to trade off between the two. So I'm just going to just whip across to a demo now, so just bear with me. Let's see if this works. So if we were to start off with a data set that looks something like this, I don't know how well you can sort of see that. Sort of resolution issues here. But effectively, you can see there's some sensitive information in there. That we can see nationality, we can see some information about location, job, phone number, salary type, age, and number of children. So effectively, these are all elements and attributes we can start to anonymize. So the way we would do that is we would, again, resolution errors. So the way we would do that, we'd just ingest this data set, ingesting that exact same data set as a CSV. And what we're going to do is effectively, you'll see what we've done is we've normalized the data sets into our own particular format. And then we're identifying the column headings and sort of mapping them to our own entity types. And once we know what the entity type is, we can then start to generate some of these resolution hierarchies and move the data into this sort of lower dimensional, lower resolution space. And so what you can see is some initial metrics about the data set pop up. So we've got a K anonymity score here, which effectively is 1 at the moment, which means there are unique records. And then we've got utility metrics, so how useful effectively the data still is on an entity-by-entity basis. And at the moment, it's at its full score. And then we're also throwing into the mix some risk metrics as well, because ultimately, what businesses care about is how risky their data set is and whether they're putting their customers at risk by sharing it with third parties or giving it to external software developers. So we try and use some measures of, or some risk modeling tools to effectively give some insight into that process. So once we've ingested the data, then we can optimize to effectively just our set of defaults, which will try and effectively anonymize the data but keep as much information as possible. So can you still see that? So it's very small here. But effectively what you can see, here I'll zoom in a bit, actually that's rubbish. So effectively what you can see is we've optimized to make bucket sizes of 3 in this case. So if you took one record, it'd be indistinguishable from 3 others, effectively. And then you can see its impact on utility over the different entities. So we've lost a little bit of utility here, 21% over this measure. And then finally, you can see, sorry, this sort of wrapping mess here, but it's effectively it's identified nationality and identified that it's an Emirati person, and then sort of generalized it to Asian, effectively. And then what that means is all the other Emiratis and other Asian countries will be lowered to that same resolution. And in doing so, we've sort of created this anonymity score. So the way we'd actually surface that up to users is via an interface like this. So instead of effectively typing in on a command line, I want a resolution of 3 or 5, you can actually effectively just work with a slider here, and then you can see its effect on risk and utility. So really, I guess what most of you are interested in is how does that actually affect the data set? So just jumping back, if I show you another example data set here. So this is some health records. Again, you can see some sensitive information. So this has been anonymized. Effectively, we put ages into age brackets. We've put body mass indexes into brackets as well. And effectively, what we're trying to predict is we're running a sort of a test here, and we're trying to predict the health charges. So there's going to be some interesting correlations, possibly. Well, I know for a fact that smoker correlates quite heavily to these the medical charges of these individuals, and this is a example Kaggle data set that we've anonymized. And so, if I just jump straight back to the presentation here, you can see the effect. So what we've done is effectively, just let that load, effectively run different levels of anonymization, and then try to predict that column at the end. So what you can see here is effectively how the regression score falls as you increase the anonymity of that data set. And so what you can see is there is initially quite a steep drop of around 20% from the initial score. These are very, very simple linear model we're using. And then it effectively plateaus out. So what that means is that effectively you can anonymize your data, protect people's privacy, but still maintain some of the accuracy on your model. And so this is effectively a tool you can use to, or businesses can use to effectively maximize privacy of users, but still carry on doing what they need to do. And these are quite high anonymity scores at the bottom as well. So you can sort of at the very end of at the very left-hand side of that graph, you can implement sort of a k-anonymity of 10 and almost, and you lose no accuracy in your algorithms. So I mean that's the sort of the technical approach. But the way we would actually implement that for a user is that a sort of data controller at a company would upload data. We'd identify the personal information automatically using some of our machine learning algorithms. They can sign that. They can sign that classification off. We apply the privacy and utility settings. We process it. We analyze the risk, and we feed all that information back to the users so they can make an informed decision and perhaps even iterate over that process until they're happy with their risk score, and then they can publish that data. That data can then be used for third-party analysis. If you're sending a data set out to an analytics company, it can be used for software development abroad, or even if you want to put it into GDPR, cold storage for GDPR regulation compliance. And that really is one key point to sort of end on, is that the GDPR doesn't apply to anonymized data. So this is going to be a really critical tool that businesses can use to maintain compliance. So a couple of little features as well to add on the end there, that the data controller or the admin user that's uploaded that data can then sort of audit and revoke access to that data set as they wish. They can generate privacy impact assessments, which all feed into the sort of helping businesses achieve compliance with the GDPR. So thank you very much for listening. We're Anon AI, we're automating data anonymization. I would love to hear any questions, and if you would like to talk to me afterwards, I'll be hanging around. Thank you very much.
Thank you. That was really nice. One question. So I think I saw some of your like continuous variables, like ages. You kind of bucket them. Is that right? You bin them. Why'd you do that? Because you're kind of changing the nature of that variable. It's not continuous. You're turning it into a categorical variable now. Why don't you just jitter it or just add some noise or whatever?
Yeah. So actually, sort of going back to so that's what I didn't sort of suggest. There's actually 3 lines on that graph. So you can see cross, bucket, and test. So to answer your question specifically, like to actually obviously get often some of these models to work, you need a float. So what we would do is we take the limits of that bucket and then select a random number from a uniform distribution across that bucket. So effectively, the data is still bucketed, but it looks like real data. And so that is effectively adding that jitter. But in order to run the anonymization maths, like working out k-anonymity, like sort of how many unique records there are, you sort of need these buckets in this categorical form. We can then transform it into usable data. But there's actually one more interesting point about this. There's 3 tests we've done here. So what we've done is we've split the data into test and training sets. And so what we've done is we've anonymized the test set, and then we've run the linear regression algorithm on that. And then we've got trained the algorithm on that test set, on that training set, and then run the same model on the test set, which hasn't been anonymized. So what that means is that what it's showing is that you can actually you can train on anonymized data and then run the models on non-anonymized data. Now what that translates to is that, for example, if you're Tesco or something, you could anonymize your data, give it to dunnhumby, they can run a bunch of analysis, they can give you the models back, and then you can run it on your raw data, and it won't be, it will still be valid, you'll still get valid results. Sorry, slight expansion on your question there. But.
Have you any additional metrics once the data has been pulled down into these aggregated forms that might, for example, give you information about the bins and the distribution across those bins?
Yeah, absolutely. So we can add columns sort of that give that information. Yeah, absolutely, because that's quite critical, right? If you're a data scientist, you want to know roughly how the data has been anonymized. So yes, we can pull those metrics in.
How anonymizable do you think that very, very high-dimensional data is? So when you start having hundreds and hundreds and maybe even thousands of columns, you can't anonymize because every row is unique, even if you bin it.
It's a good point. The higher the dimensionality, the stricter it correlates to the number of records. So the more records you have, effectively, the more dimensions you can have to achieve sort of lower levels of bucket sizes.
But the problem is that you have a combinatorial explosion in columns, but not in records, right? So your records will have to be on 10 to the power of 14 for you to have hundreds of columns.
Yeah, exactly. It depends. If all those records are sensitive, if all those columns are sensitive, then you may have a problem anonymizing your data set. But if you're dealing with sort of customer databases or often these data sets that simple analysis on, that they are low dimensional. So it is a solvable problem. But you're right, the higher dimensional data set, the more tricky it becomes. It does actually become more interesting as well when you have a sort of database with multiple tables in it. You want to look across the tables and how you anonymize that. So there are additional complexities. Yeah.
Thank you for your talk. Would you mind explaining to me a little bit more detail about how you compute that risk score for each of the data fields? Because I can understand how, name, age, sex, et cetera, like you might see that as identifying, therefore more risky, but you can also see how that would be context dependent, depending on what kind of data you're actually gathering.
Yeah, absolutely. So the models we implement at the moment are kind of strictly academic. So, i.e., if the intention of an individual was to identify one person in that data set, how likely is it that they could do that? And there's other sort of weaker models, like, I don't know, you just want to infer something about a particular portion of the population in which the risk score will be higher. And it's all just relates back to the bucket sizes and how unique the sort of data, the points in the data set are. But that's sort of only part of the problem, really, because a major problem with anonymization is the concept of linkage attacks. So if you have another data source that's been publicly published somewhere, you potentially could do some cross-referencing and identify the individuals against your anonymous data sets. A good example is that Netflix publishing a data set that they stripped the names and emails out of, but ultimately they had timestamps when people were watching movies and then jumping onto IMDb, rating those movies, and the time, because there's a high-dimensional data set, there was enough sort of correlation between them for people to work out some individuals. So, sort of encapsulating all of that knowledge is difficult for individual businesses. So what we're trying to do is effectively encapsulate some of that understanding in these risk scores.
Hi, thank you for the talk. Very interesting. I was curious, in fields like differential privacy, there is already an approach and a mechanism towards quantifying the amount of privacy protected, gained, or lost under the right conditions, keeping track of privacy budgets and so on.
Yeah.
Is there any kind of guarantee that comes from Siri that you can offer about the quality of anonymization that you provide under different conditions?
So guarantees about the quality of anonymization.
Right.
Well, so these are well-standardized scores. You've got K-anonymity. I showed you there. This is sort of the minimum bucket size. So there are two fields of research on this. You're right. This is the more modern sort of differential privacy approach, which works very well on a query-by-query basis onto a data set where you can keep track of what people have seen, and you can add noise to the results if necessary. But you're right. There's a limited privacy budget with that approach. So i.e. if you make too many queries and requests, your access gets revoked, for example. With these bucketing strategies, you have a baseline privacy metric, and that can be K-anonymity, that can be L-diversity, that can be T-closeness, all of these different techniques to sort of measuring the uniqueness of the buckets. And that's once you get that data set into that form, you can do an unlimited amount of queries on it. You can effectively use it in many more ways. So we're taking this sort of bucketing approach at the moment. Does that sort of answer your question?
Kind of. I understand there is a metric you can measure, but what I'm looking for, and maybe it's just my ignorance here, is some way to map from that metric to a specific promise you can make about how difficult or impossible it is to reverse a individual record from
I see what you mean.
Conditions.
Yeah. So a key sort of problem with anonymization is making the guarantee that we couldn't give you a data set and said there is zero possibility of someone being able to find some other data set somewhere else that they could cross-reference it with yours and do a de-identification, because theoretically speaking, that's just not possible. There could be someone that exists in the world that has unlimited resource, has access to all the data sets in the world. I mean, potentially Google is this person, but there are people out. You can't sort of factor all of these into this equation. So the risk of re-identification is always going to be zero. At this very minimum, there's a very small chance. You can never make it zero effectively.
Right. Sorry, maybe I'm hugging the microphone. Just the last question on this, or last follow-up. My question is not really whether this risk can be zero or not. My question is, can there be a way to principally reason about, for a particular data set and particular anonymization strategy, what is that risk?
So yes, I think that's why we're trying to apply these risk models. And as I say, these are sort of relatively standardized measures of risk as well, i.e. if someone had this intention, how likely are they to be able to identify individuals. So yeah, you can quantify it. It is a little bit theoretical, but at least it gives some insight for the businesses that are trying to make these decisions.
Thank you.
All right. Thank you, Ari.
Thank you.